Thanks, Tom. The next slide, please. So I'm a river ecologist, and when I go to workshops or conferences, people like to ask an icebreaker, which is, what's your favorite river? Which a river ecologist might feel a little like picking your favorite child, right? You never want to do that. But I always say the American River, and people tend to give me some weird looks if they know that it's an urban river, it's in Sacramento. Why would I pick that? Most people tend to pick some high mountain stream that's, pristine. But it really is my favorite river. I'm not lying about that. I live near the river. I spend a lot of time out there. A couple times a week I go out with my family, and it's really, for me, a big part, a big draw, a big reason why I love living in Sacramento. And especially now, we've all been home. I have two kids who are doing school at home, and my husband and I are working at home, and it's been a real refuge for us. These are photos that I've taken just the spring and summer out along the parkway and the river, and I find it, maybe because I grew up in Los Angeles and my home river was the LA River, but I find it to be really an amazing resource and a big benefit and a big reason why I love living in Sacramento. Next slide, thanks. But it's really one of the hardest working rivers in the state, which makes it more amazing that we see such nature and such biodiversity around us. And it's been this way since the gold rush. It was, the center of gold mining in California, and we still see the effects of the hydraulic mining along the river and the river channel and along the parkway. It has a big dam, and the dam supplies water for the Sacramento region, but then it's also part of the massive water infrastructure for California. So we manage not only for our region, but for the whole state. It's a big recreational resource. I took this photo of anglers just last weekend fishing for salmon along the river. And then it supports the fall run Chinook salmon and steelhead populations for the Central Valley. It's a big piece of the Central Valley salmon production. Next slide. And we know that the world around us is changing. Tony talked a lot about this, and Tamika, but we are seeing the effects of climate change here. We're seeing warmer temperatures. It's really noticeable now in the summer and fall, but really all year. We are already seeing reduced snowpack that we think is only going to become more pronounced, and that'll make it harder to manage our water. We are expecting longer dry seasons, so drier springs and falls, and then increases in both floods and drought. So this weather whiplash that climate scientists like Daniel Swain talks about, where we would move between really wet years and really dry years. And then on top of that, we're getting these more intense and severe wildfires. And that's hard enough to manage on its own, but these climate change effects really interact with human modifications. And I'm going to talk about these 4 things in more detail, including habitat loss, water management, both flow and temperature, habitat condition in the river, and influences of the hatchery. Next slide. As part of my work with the Nature Conservancy, I'm sorry, let me start with this one. I'm going to talk about habitat loss. So this map on the left shows anadromous fish habitat for the Central Valley. And in the black is habitat that has been blocked by dams. So there was a lot of anadromous fish habitat that is now no longer accessible because of dams we've built. So what is in blue is what's now available. And the panel on the right shows that same, just zooms in for the American River. So what's in red is all the anadromous fish habitat that's no longer accessible. So Folsom Dam was built pretty close to the confluence with the Sacramento River. We used to have over 125 miles of anadromous fish habitat, and now we only have 23. So those fish need to complete their whole life cycle in this fairly short stretch of river and don't have access to higher elevations and colder water. So we're really managing in a small space for what used to be a pretty large accessible watershed. Next slide. And with my work with the Nature Conservancy, what I'm working on now is a lot to do with natural flows and what kinds of flow regimes we need to protect to support ecosystems. we developed this tool called the California Natural Flows web tool, where you can go to any river reach in the state, all of these that are blue here, and download monthly predicted natural flow data from 1950 to 2015. We're currently working on updating that, as well as functional flow metrics. And I just pulled out some of the visualizations for the Lower American just downstream of Lake Natoma. And the top panel here on the right in purple are observed flows. These are our monthly averages across the period of record. And then in the blue, that middle line are mean monthly flows. And then the top and bottom line are 10th and 90th prediction intervals. And it shows you that observed flows downstream of the dam are much less variable than natural flows. And so we put in Folsom Dam and we did what we wanted to do with it, right? We stored water during the wet season so that it was available during the dry season. And we really evened out a flow regime that was naturally variable. The problem is that for ecosystems, these species depend on variable flow regimes. So that's where we have this conflict between what's good for people and what's good for the fish in the lower river. Next slide. And this, when you average across a whole period of record, you can see these bigger patterns, but sometimes it helps to look at specific years. So this is the same data. In blue, we have observed flows, and then the dark gray are monthly means, and then the light gray are the prediction intervals. And this shows water years 2011 through 2015. So 2011 was a really wet year, and then the other 4 were all during our big, most recent drought. And what we can see here is that in 2011, our observed flow was pretty close to predicted natural. We got a lot of flow variability. Flows were higher during the wet season than in the dry season. But when we got into the drought, the dam now could store all that water during the wet season. And so we see a flipped hydrograph where our lowest flows of the year are in the wet season and our highest flows in the river, what's being experienced by the ecosystem, are now in the summer. Next slide. And I've been working with a big group of partners on what we're calling the California Environmental Flows Framework, which is a way to set ecological flow criteria for all streams in the state. And it's based on 5 key functional flow components that are necessary to support ecosystems. These include fall pulse flows, which is that transition from the dry season to the wet season base flows, peak magnitude flows, which aren't the kinds of floods that would impact people, but they're meant to just inundate rearing habitat and some of the channel margins. Spring recession flows, which is the transition between the wet season and the dry season, and then dry season base flow. So based on the scientific literature, these are functional flow components that are really important for life history stages of different species and pretty much show up in most of the streams in California. Next slide. And so what I did here was I just pulled out 2 years, the water year 2011, which was really wet, and then the next slide will be water year 2015, which was really dry. And I overlaid the predictions for the functional flow metrics from the website on that hydrograph, just to see how we did. And we predicted values, this is for the Lower American downstream of the dam, and we made different predictions for wet years and dry years. So these are the values for a wet year. And you can see that we have this natural variability. Even with the dam there, Folsom Dam is fairly small. It can't capture a lot of water in really wet years. And so we did see some 10-year peak flow events. There was one that happened in December and then one that was a little bit lower that happened in March. We do see a spring recession. So we see some of these patterns. And what's also really important is that temperatures were low in that year. So the maximum temperature in September was 17 degrees Celsius, which is about 62, 63 degrees Fahrenheit, which is right where we want it to be. So we have 65 degrees is a target where if you go above that, it's really detrimental for anadromous fish like steelhead. So in this year, fish did really well. Next slide. And if we compare that to 2015, this is, well into the drought. This is towards the end. And we were storing all the water we can. And you can see this flipped hydrograph. It's really evident. The whole winter flows were really low. And the highest flow of the year was in July, which is completely opposite from what you would want under natural conditions. And then temperatures were really warm. So our maximum September temperature was 22 degrees. So that's about 72 degrees Fahrenheit. And that can cause mortality. I mean, that's well above the threshold that where we want to keep temperatures for anadromous fish. Next slide. So if you can go back just one. So when we think about flow and temperature, those are two parts of the river, but then we also think about habitat. So the river, the habitat in the river has been modified for years. If anybody who's been out walking along the parkway has seen these big gravel piles, and these are left over from mining operations. This isn't something that's new. This is all substrate gravel that could have been used for spawning. It all would have been in the river channel and had been taken out during mining. We also have a lot of gravel that's trapped behind the dam, so we can't replenish what was there because the dam traps it from moving down from the mountains. Next slide. And then the channel itself is modified in a lot of places. So this is just a photo I took near Sacramento Bar. A lot of our banks are fairly steep. So when you do get higher flows, you don't inundate a whole lot of habitat because it's a pretty steep bank. And then in the channel itself, the substrate is often too big for fish to be able to move to build redds to spawn. Next slide. And so the last thing I wanted to talk about is the threat were hatcheries. So this is a figure that shows fall run salmon escapement. So these are the adults coming back to the river every year from when Folsom Dam was built to current. The dark blue line shows fish that return that were natural production, and that turquoise line are fish that return and spawn in river but were hatchery origin. So the first bar I have outlined in red were the adults that came back that would have been juveniles during that wet water year in 2011. So they left during that wet year and then they came back, and that was a pretty high escapement year relative to the others around it. And if you look at that top kind of turquoise section there, the hatchery fish were a relatively small proportion of the total. But the next bar outlined in red to the right were the adults that came back after that really low water year in 2015. And not only were the total returns pretty low, but now hatchery fish were about half of the total proportion of fish returning. So when we have really stressful conditions in the river, that's when we lose our local population and it gets replaced by fish that are hatchery origin. Next slide. So what do we do about this? We have a really complex management situation, right? We have a dam that's providing water for a lot of people. We have changing climate. We have temperature issues. We have flow issues. We have habitat issues. We need to figure out collaborative solutions that can balance all these things. And so the Water Forum they brought scientists together to develop the modified flow management standard. And they determined that during the spring, this chart right here shows fall run salmon life history stages and then steelhead life history stages. And the spring months, which are the columns in light blue, flow was a stressor. So in those months, flow should be inundating habitat for juveniles to rear and to grow and to be able to leave the river. But then when you get into June through November, temperature becomes the stressor. So during those times of year, temperatures are high and can cause mortality. Next slide. And when we look at data, we see that that is really the case. So this figure shows water temperatures from 2004 to 2008, and everything shaded in red means that temperatures were too high for fish. So in 3 of these 5 years, the temperatures in the summer were higher than 65 degrees, which is very stressful. And in every year, the temperatures in the fall were higher than 56 degrees, which is where you want to get down to for fall run salmon spawning. So temperature is a big problem. Next slide. And so this group worked together to say, well, how do we balance flow and temperature? And they came up with the flow management standard, which said that we, in this case, should sacrifice some natural flows to provide for low temperatures in the summer, but we still want to maintain flows to inundate enough habitat to allow fish to survive. So, and then also not draw down the reservoir. So this is a case, I think, where we had to, different scientists had to get together and really work on how to balance these competing objectives in order to support fish in these really stressful years. Next slide. And then what about the habitat? So it doesn't help to do a bunch of balancing and figure out what to do about flow and temperature if you don't have the habitat to support them. And you need that in every year. So when we have really wet water years, the fish do really well. So those years like 2011, those are the ones that really support the population. And then in the other years, like 2015, you're just trying not to kill everything and just make sure they survive. But in all years, you need habitat. And the nice thing about working in the American River is that it's publicly owned land. We can do projects. We don't have to worry about dealing with private landowners. And we have a lot of people that can come together and design these projects to create good habitat conditions. This is a photo from a project that was done in Sailor Bar. This is what it looked like before a habitat restoration project. And then the next slide shows after. And then you can see all that gravel that was added to the river. And next slide. After some monitoring, we looked at the fish that had gone out there. This is not actually the Sailor Bar project, but this was another one in Nimbus Basin. And all those dots are salmon reds. So this is a place where salmon actually couldn't access the Nimbus Basin at all. We did a restoration project. We found reds all throughout there, and over 90% of them were in what had been designed to be high quality habitat. So the design of the restoration project really worked. Next slide. So we used to really focus on spawning habitat. I don't know if you can go back one because these figures got on top of each other, but we used to only focus on spawning habitat. Oh, they must just have, okay, gone to, that's fine. But we used to only focus on spawning habitat, but then over time, we realized that we really needed to focus more on rearing habitat as well, because we were seeing a lot of mortality of juveniles as they left the river. And so the animation didn't work out here, but the figure in the back shows some modeling that we did. I worked on it with Kramer Fish Sciences, Joe Mers and Travis Sinkelman, to model how much rearing habitat would you need in rivers throughout the Central Valley if you were to support juvenile salmon populations. And this just shows a graph for the American River. You can actually go to the website if anybody wants it. I can send it to them and play around with it and look at it for different rivers yourself. And we came up with somewhere around 30 acres using some assumptions about habitat suitability. And then when we did monitoring, we saw that in these restored sites, we really did find a lot more juvenile salmon than in the ones that hadn't been restored. So this combination of spawning and rearing habitat restoration does seem to make a big difference. Next slide. And this is what it looks like in some of those places. So you can see with habitat restoration, you're just inundating some of the channel margins, you're having shallower water, slowing it down. And then a lot of what we're trying to do is add large wood to provide some cover and structure for fish. And that's where you really find a lot of the juvenile salmon when you go out there and look. Next slide. So we've been focusing a lot of our management on the lower river, and traditionally, we're thinking downstream of the dam, but I think with all the challenges in the future, we need to think more about the whole watershed. And so as Tony mentioned earlier, the Nature Conservancy has been working with PCWA and the Forest Service and other partners to look at different forest thinning strategies and different ways of doing a mosaic of forest management, and shown that can improve water quality. It can also decrease fire severity, and it also can increase water availability. So I think in the future, we need to probably broaden our perspective a little bit and think about the watershed as a whole. Next slide. So just to wrap up, the American River is a really hard working river, but I think it's also a demonstration that we can have a really healthy urban river if we think about all the stressors and how we can work together to try to alleviate those. And I really credit the Water Forum with bringing together all these diverse stakeholders, the federal government and the state and NGOs and water districts and all of us together, that it's the one place where I feel like we all are really working towards a common goal. And I think we've seen the benefits of that. Next slide. I wanted to end with an activity here. So it's mid-October and there are fall run salmon in the river. And so they're gonna start spawning in November. And I just wanted to suggest and encourage everybody to get out and to go see them spawning for themselves. And there's lots of places to do this, but this is my favorite place to go. I like to start in Fair Oaks Village up in the upper left there and cross the Fair Oaks pedestrian bridge. And when I get to the other side of the river, I turn left, I go upriver, I pass the Sunrise boat ramp, that plaque right there that says Upper Sunrise, you'll see when you start going by the Upper Sunrise side channel. And at the upstream end of the side channel, this photo in the upper right, you'll see this kind of weird tree right here. And there's a couple little trails you can get to the edge. It's right by the bike trail. You can get a great view over the Upper Sunrise side channel, which is this bottom right photo. And there are tons of salmon spawning in the river. And I would encourage everyone to get out, see the natural salmon spawning in a restored site. And the next slide is my final one. This is a video I took last year, if it'll play, with my family when we were out watching the salmon. So I hope everybody gets a chance to go out there. It's a great marker of fall. It's the way I celebrate fall in Sacramento. And thank you. I'll take some questions.
But don't go out there right now. We still have more program for you.
Right.
Julie,
right. It's not an activity for right now. Later.
Not right now. Not right. Julie, thank you very much. The world's going to be floodier. It's going to be droughtier, and we're going to feel those stressors, and our environment's going to feel those stressors. And so, Grace, do you have a couple of questions for Julie? Grace or Lily? Grace, it looks like you might have frozen. Lily, do you have a backup?
I think you're on mute, Lily. I don't hear you.
Is this better?
Yes. Mm-hmm.
How do you anticipate the governor's executive order will impact our waterways?
I assume you are talking about the 30% protected areas. Yeah, so I've been actually wondering that myself. I don't have an answer for that. I think a lot of it, so I'm a scientist, and when I hear these things, the first thing I think about is how are we going to define what's protected, right? And I think it all kind of comes down to that. Are there places where we have any kind of management actions, or is it places where we've actually looked at outcomes to say that we truly are seeing an ecosystem response? And I feel like this is an unsatisfactory answer, but I just want to know a lot more. I'm really encouraged by it, but I just want to know a lot more about the definitions first and how we're going to measure it.
Great. Do we have another one? We have time for at least one more, maybe two more.
All right. Can you hear me?
Yeah.
Yay.
Okay. Yay. All right. You had mentioned the forest thinning efforts, and I'd like to know what other efforts are currently underway for habitat restoration, and are those efforts ever coupled with the forest thinning efforts?
Right. So the group so I am Nature Conservancy, right? And the group in the Nature Conservancy working on forest thinning is part of our lands program forest team, and I'm on the water team, right? So we're a little bit different. I work on mostly flow in the lower river. They're doing forests up in the larger watershed. So we're not, I think we've been talking about trying to coordinate our actions. We haven't really done that well yet. I think that's something we need to do more of, but I know I've been talking to Kristen Wilson, who's worked on that project a lot, and they have been monitoring water availability as an outcome from the forest management. And I think trying to put some more of those indicators of river health in there would be a good way for us to try to pair those actions. But they are, I mean, they do have a really great study going up there. They're looking at, different treatments where you have kind of dense forests and then open forests and in between, and looking at mosaics of the forest habitat and really seeing some good results.
One more. If we can do it in 1 minute, we can do one more question.
All right, this one came in through the chat. We just did a bike ride on Sunday. My 10-year-old daughter and I watched the salmon. She had questions about when the fish ladder project will be finished and if we can feed the fish again at the hatchery that is currently closed. I enjoyed seeing the changes being planned and worked on over the years. What is the best way for me to educate her more about the real-time fish spawning in the river, besides the data on the water form? Is there more online right now?
Right. So the hatchery, I have not been involved with the latter project. So Tom might have more information about when that'll be done. I do have a friend that works at the hatchery that I could always reach out.
Couple of years, year and a
Couple of
half to 2 years.
Okay, yeah,
Yeah.
a couple of years. Yeah, so I feel like we don't have a ton of opportunities for organized trips to go see salmon spawning in the river. That's why I wanted to give you a great, I mean, that's my favorite place at Upper Sunrise Side Channel, because you can see so much going on right from the bike path. In the past, Tom's been part of this. I've tried to get school groups out to do field trips to learn more about that. We actually have salmon that are spawning in the river. They're not all in the hatchery, but I feel that that's kind of a missing piece for us in Sacramento, is to make sure people know. I see people out all the time on the pedestrian bridge who are talking about the salmon, and they're like, why aren't they going to the hatchery like they're supposed to go there? And I think that it's important that we all know that they're not supposed to go there necessarily. There's a lot that are supposed to stay in the river, and they're meant to be doing that.
All right, Julie, thank you. Everyone, virtual round of applause.